Another important concept within object orientation is the concept of polymorphism that allows us to define methods in child classes with the same name as defined in their parent class with the same behavior or different behaviors up to us. This is pretty useful for us to define new actions given the same name of a function or method. Some classes, they allow us to use polymorphisms, like in C++. You can have this without using inheritance and classes. You can simply define functions with the same name, and if you use a different signature as the parameter list, you have a different behavior. In Python, this does not work that way. We're going to see an example at the end of this tutorial, but think as the following. Imagine that we have a class called Bob, and Bob does not belong to anyone, and let's say we have here a function called say, and this here is simply prints I'm Bob. And then, oops, I am Bob, like this. And then we're gonna have another function. And in this function right here is Bob's son. And then Bob's son is extending from Bob. And then Bob's son will have also a function called say, and that will pretty much do the same thing, but in a different way. We'll also say something, but we'll say something like, I am not Bob, I am his son, or something like this. So the idea for us to have functions with the same name, but with different behavior, it's pretty much what shows about polymorphism. So we've seen this in the example with the previous example with the inheritance between the animals. If you take a look on the definitions of functions with hunter and aqua hunter, you see pretty much we're using, but there the function was run, the method was run, right? So let's take a look in our example here. We have one class. This class is called bird, and we have an intro for every bird, and also we have a flight function. So we say that an intro is there are many types of birds, and the flight function will say most of the birds can fly, but some cannot. And then we have two other classes, which they are extending the class bird, as we can see here. So we have sparrow and ostrich. Both of them extend bird, and each of them, they have the same function named flight with a different behavior, like sparrows can fly and ostriches cannot fly. And then if we take a look here in our main class for polymorphism, what we have three objects: a bird, a sparrow, and an ostrich. Remembering that sparrow and ostrich, they are from the class bird. They are inheriting everything from the class bird, but the flight function has a different behavior from bird, from sparrow, and ostrich. As we saw, each of them is implementing the flight function in a different way. All of them, as we see here, we can call the function intro from sparrow and ostrich. Why? Because this is coming from the bird class in which they are inheriting. But we don't specifically implement them. We just use the same function that we had in the base class. So if we run our code here, we'll see that all of them, they have the same message for intro. Like there are many types of birds. So if we go here, we saw that this here, it's triggered every time we have the function intro being called. And then every object which is calling the function flight, and as we can see, the first one here is from the bird class. The second one is from the sparrow class. And then the third one is from the ostrich class. They have different behavior. So the polymorphism here, it changed the behavior of the function, right? We also included another example in this here to talk about how we cannot have functions with the same name within the same class. Otherwise, just the last definition is going to be triggered. So as we can see here, for example, we have two classes, bad cake and good cake. Within bad cake, we have two functions called make cake, which we pass nothing, just the object itself. And then we have the make cake with some stuff that we are providing. If we go ahead there and let's comment this, I'll talk about how to fix this in a minute. And let's say we want to run the bad cake function and see what's going to happen. If we try to run this and we call the function make cake, it's saying that's missing one positional argument, and we already talked about what is a positional argument. We can just verify this in the past videos. So it's saying here that's missing some stuff. And what is the stuff? I mean, I have a method here that does not need stuff. Yeah, but since we have two definitions, the last one here is being triggered. So it doesn't work that way as in other languages, as in C++. All right. Or in Java as well, I think. But in any case, let's see how we can fix that, right? Let's comment this here. We don't want to take a look on this right now. We just want to create an object, and then let's input something from the user, and then we can just print it out the information. So how do we move from this structure to a better one so I can use both of them? Like if something is provided, I'm gonna go there and use that information. If it's not provided, I wanted to just use my function the way it is, and that's life. We already talked about this. We can use a keyword argument in which the value is optional. So if something is passed, then it's good. I'm going to go there and I'm going to use a specific behavior, the same one as we defined in the bad cake on the second make cake method. Now, if something was not passed, well, just go ahead and print the default behavior, right? So if you go there and let's just run our function, our program, sorry. So we go there, provide a special ingredient. Oh, let's say special ingredient like sugar, which is not special, but that's all right. If we go there, we see that the make cake function was executed with the information that we provided, with the stuff that was provided. So when this here, it ran, this is the function that ran. So we verify the value of stuff, and then we printed out this information right here. Okay, so this pretty much sums up polymorphism. Thank you and happy coding.